Okay, today we're going to be talking about single pole double throw switches, or SPDTs, otherwise known as three-way switches. We're going to talk about some of the differences and kind of how they work, some of the major things that we need to focus on. These are switches that people will often mess up when wiring. You may have in your home a set of two switches, typically like in a hallway, where one switch will flip it on, you go to the other one, it flips it off. So typically where we have more than one entrance is where you see three-way switches. But you may have one, or you may have been in a house or somewhere where one switch has to be in one position for the other one to work. We're going to learn why that happens, or what happens when you do that. It's wired incorrectly. It's not a safety hazard. It's just not doing what it's intended to do, what its proper usage is. So we're going to kind of cover that, go over some of those things as we go through with this stuff. So moving forward, some of the major differences that we see from a single pole single throw switch to a single pole double throw switch are kind of noted right here. Regular switches, they're going to have the two brass terminals you can see on this left-hand side. The smaller, skinnier one is the single pole single throw. That is not necessarily an indication, although in sometimes some of the stuff that we have, it's a pretty good way for us to tell. All of our single pole single throw switches are going to be skinny, but that's not true all the time. How you can identify it is that there is two brass terminals and a green screw for your grounding. That's it. On a single pole single throw, there's nothing more than just that. We can identify these things by having the on and off as well. That is a major way of doing that. The three-way switches, there is no on and off on there. The three-way switches, in addition to having two brass terminals, like the single pole single throw, it's also going to have one black terminal. And you can see on the picture on the right, you can see the difference where that screw is black versus the brass that we have on these. There's no on and off. Here's the two brass. There's the black wire. That black wire is the key in how these systems work, how we can actually get a three-way switch or a single pole double throw switch to actually work. Just kind of a little side note, single pole, single throw, that's where we're getting it. There's one entrance, one exit. On a single pole double throw, we have the black, which is our single pole, and the brass, which is our double throw. So that's where we're getting the name single pole double throw or single pole single throw. So that black terminal is what we consider the common. And if you've looked at some of the stuff on the diagrams, how to wire up diagram number 1 and 2, we mentioned the common terminal in there. This is where this stuff is going to come into play. It's called the common terminal because it is always going to be connected to one of the two brass terminals. So it's either going to be connected to one, or it's going to be connected to the other. So it's common. It's always connected. It's always got some sort of connection with one of those brass terminals. This little diagram kind of essentially what's going on in here. This isn't exactly how it happens, but essentially with this switch, you are taking, if this switch is in like the up position, it's going to be connected that common terminal to that brass. If I were to flip that switch down, the connection moves from that common terminal up to the opposite brass. Okay, so we're going basically back and forth. We'll just kind of click this so you can kind of see. We flip the switch, it's up. We flip the switch down, it goes across. This may not be exactly how it's working. If it's down, it may be connected to the one right above it. Also noting that this common may be in different places. It may not always be on this place. It may be on this side. It may be up there. The two brasses may be on one side. It depends on the manufacturer. There is no guaranteed where that thing is going to be at. You want to look, find the black terminal. If you can't find the black terminal, let's say these things are kind of worn down. If you look real closely, you can see that it actually says common. So it's going to say it on the top. Sometimes it's going to say it on the bottom, maybe in both places. You're going to see the words common written on there. So when you're in class and you're actually wiring these things up, or if you're ever out on your own and you're replacing switches in your house, look for that common. Look for what it says the common is. That's going to be the indication. That's where things are going to be connecting to. I mean, they're connecting to all the brass terminals, but that's the one that we really want to focus on because that's where people typically mess up. So we flip it down, it goes on the other side. Okay. The reason that this matters is we need to create a path for the electricity to flow. And everything when we deal with electricity is talking about paths. So we want to have a path that's going to be able to flow. And hooking these things up, okay, is going to give us the connection that's going to continue that flow. Otherwise, it might disrupt that flow. With a single pole, single throw switch, that's not a problem. Our intent is to disrupt the flow and then connect it, and we're doing that at a single point. With these three-way switches, we're trying to do that at two separate points. So two separate points need to act independently, but are also dependent on the other thing, if that makes sense. That might be a bit confusing, but it'll make sense. Okay. Understand that that common is the key to how these switches work and how we get them to function like we should. So now that we've got like that basic understanding of kind of what's going on, how these switches are connecting on the inside of them, we're going to do a pretty simple kind of wiring diagram that we're going to hook up. Now, the first rule of thumb, and this is the thing that you need to think about, because we're going to do one diagram together, and then there's going to be two other ones that you're going to have to do on your own. And so these rules that we're going to set up is going to help you when you actually go to wire up the other diagrams that we are not going to work on together. Those common terminals, one common terminal, not both, one common terminal needs to go to your source, and the other one is going to connect to your load. So one common goes to my source. That's going to be that little arrow. That's where our power or our plug is coming into on our boards. And then the load is going to be the light. It could be an outlet or whatever, something that is going to be using that electricity. That is our load. In this case, it's going to be our light. Follow that rule. That's like the first thing that you should really focus on. And it's going to help eliminate 99% of the errors that you may find with these systems. Okay. One common's going to go to your source. The other common's going to go to your load. Now, which one we do might change, and it will change. Some of it might matter more. Some of it may be completely up to your discretion. You can do the neutral wire, and this might be a good idea. I told you to do the commons first. The neutrals may not be a bad idea. So in this case, we've got our neutral wire. We're going to bring that back. We've got a wire net. We're going to bring it into this box. We're going to wire net it. We're going to carry that stuff back. What this is going to indicate is whether or not we may be using a white wire as a hot. In this system, we're not going to need a white wire as a hot because we need the white wire as a neutral. In some of these cases, you may be using the white wires as a hot wire. So if you carry the neutrals back, that's a great way to kind of just eliminate, am I going to use it as a hot wire or not? Because if you have to use it as a neutral, you're not going to put two of them in there. Then we're going to follow that rule, one common to your source. I'm going to pick this common to go to my source because that common is closer to here. Likewise, I'm going to take my other common and I'm going to connect that to my load. This is a brass terminal, by the way. It's not the black like we have in our diagrams, but I kind of made it brass because we have color, so we can do that on this PowerPoint. So the rules are one common to your source, the other common to your load. We're not connecting both of them to the same source or the same load. We're not connecting the commons to each other. That is going to be wired up incorrectly, and power will cease to flow if we do that at some point. That's when it's going to give you that situation where one switch has to be flipped up so that way the other one can actually turn it on. Now, these brass terminals, these things are very, very simple. Do not overcomplicate that. We want one brass terminal that's going to go over to the other brass terminal on the other switch, and then the other brass terminal is going to connect to the other brass. These are called our traveler wires. We want to connect these things to each other. Now, theoretically, it doesn't matter. You can flip these things around. So I could flip this red and that black wire. This system is going to work. It's not going to have a problem. Everything will function normally. That's not a safety issue. I like to connect that brass terminal to the same one, so it's on the same exact side. I just like to connect it there. It makes it easy. We can't do a black wire here because we've already have a black wire with that traveler. That's where the red wires come in and why we're going to use red wires to connect those things. So if we were to kind of follow this path here, if we connect those traveler wires that we have within these systems, we connect our neutrals, which we've already done. And we're going to kind of take these things. We're going to follow the path or the flow of electricity. So we're going to take our mouse. We're going to kind of drag this across. So we know that power comes from our hot source. What we're going to do is we're going to come into our common. If this switch is flipped down, that orientation is going to be giving power to the red wire. Power will flow into that red wire. If that switch is also flipped down the other side, power is going to flow into here. It's going to go to my light, and then we're going to be able to return. So that is going to cause power to stay. If we were to flip this switch, so if we were to take this switch and flip it up, you notice the light comes off. Power is still flowing from here into the red wire. We have now disrupted the connection to our load by flipping this switch up. And so power is now wanting to take this path on this black wire for that light to be able to turn on. So power is disrupted. It's not flowing. If I were to take that other switch there and I were to flip that thing over, flip it up, I did nothing to this side. This side, when I flipped it up, it turned it off. When I flip this side, power now is going to come in, and instead of being on the red wire like it was before, power is going to be on the black wire. So now we're going to follow it, and we can follow power all the way through. If we were to flip this other switch again, back down to its original position, power is still flowing up through the black wire. We have now disrupted it here, and power is basically going to go through. Now, we could take this thing and we could flip this switch. If we go in reverse, if I were to flip this other switch here, flip that down, I'm disrupting power from this black circuit, and now I'm putting it on that red circuit again where it's also disrupted here. So we're disrupting it in there. We essentially have two paths for this electricity to flow. Instead of just breaking the path like we do with a single pole, single throw switch, we're just switching it from one path to the other. And then it's going to be dependent on where the other switch is at. But that's why one flip of the switch is going to allow us to basically turn on or off the light, change whatever position it's in, and then we can always change the other one. The advantages, right? We go to bed, we want to walk down our hallway at night, we want to have the light, but then we want to be able to shut that light off at the end of the hallway. So we can shut that stuff off. I want to be able to turn that back in, or somebody else comes in. They need the lights on. So they go into the hallway, they turn the other switch on, and they can turn it off. And you can work that in any kind of way. That's how three-way switches should work. That's what should happen. One switch flips, and the light is going to change from on or off. It doesn't matter where it's at, but it's going to change. If you do that correctly, that's how we get these three-way switches to work. We're going to do a diagram in the next video. I'm going to show you guys how we actually diagram this stuff on ours. Even though this is kind of there, this is not necessarily a complete stuff. We don't have our ground wires, but we're going to do it on our diagrams in the next video.